Welcome, everyone, to this informational webinar sponsored by the American Mathematical Society. We are focusing today on the Mathematics Research Communities Program for 2023. Today we have panelists who are some of the organizers for each of those workshops, and we are very pleased to have them here to talk a little bit about their individual programs, as well as we'll be discussing a little bit about the overall program. So we invite you, well, here is the webinar agenda, very simple. My name is Tom Barr. I'm Director of Education and Strategic Partnerships at the American Mathematical Society, and I will be the moderator for the panel. I'll begin by providing some general information as indicated on the webinar agenda here. Then each of the panel groups will spend a few minutes talking about their topical areas, the ones that they'll be focusing on in their summer conferences. And then the balance of our time here will be focused on Q&A. So welcome all. Let me say a few things about logistics maybe before we go any further. Karen Wargo, a staff member here at AMS, will be providing staff support on this and monitoring the chat as we go along. If you'd like to put questions in the chat, that will be fine. You will, though, in the Q&A have an opportunity to raise your hand and actually talk to articulate questions. So this is an opportunity to get some information, to meet the organizers, and in the end, we hope to provide some encouragement to apply for one of this year's programs. So overall, the Mathematics Research Communities has a fairly straightforward objective. It's here to support the development of collaborative research skills for early career mathematicians, to provide context for those early career people to build a research network with their peers and leaders in the research area, and also to receive mentoring from the organizers. So it's one of AMS's flagship programs, and we're very proud to be able to offer this. The summer conferences are the centerpiece of the program. Those for this session will take place in the latter part of May and June of 2023. Those are 1 week in duration. And the intention there is that they be an intensive collaborative research experience with both the peers and also the leaders that are the organizers. These conferences are slated to take place at the Beaver Hollow Conference Center, which is in upstate New York, near Buffalo. The photograph you see here is a view from one of the buildings there. It's a site that's conducive to getting away from some of the distractions that ordinary life may have, and allows people to focus a little more on getting to know one another and the mathematics they're centered around. We do call this a program. So besides the conferences, the MRC program has special sessions built into the joint mathematics meetings for 2024. Those are in San Francisco that year. The program provides travel support for participants and organizers to go to the joint meetings in 24. The program also provides support for follow-up collaborations based on applications and available funding. And in addition to that, there are opportunities throughout the year following the summer conferences for participants to enjoy community building in other ways. So here are a couple of quotes from past participants. This is feedback that they've provided in response to our follow-up on summer conferences. As you can see, their endorsement, and these are pretty typical, is that this is a very special and helpful sort of experience. Participants usually wind up in small research groups, and their work continues well past the summer conferences, where those groups have formed and taken shape. And this is, though we call these conferences, they are not necessarily talking head sorts of experiences. They are experiences that involve hands-on collaboration in these small groups with real research problems. And the word amazing comes up pretty often. So the second quote here is not atypical in that way. I'll say just a few things about the application process. In general, we are focused on early career mathematicians. Our definition of that is pre-PhD 2 years to post-PhD 5 years. Sometimes there's a little room for varying with that. That's something that can be addressed in an application, and something that may be addressed by the organizers as well. Generally speaking, when people apply to the program, they should identify one that they are most interested in and, in their view, most qualified for. You can actually apply to more than one, but in any event, you can only participate in at most one for this year. If someone is applying a second time after having participated in times past, then the applicant should address that in their application form. The link to the form is listed here. We'll say a little more about that later. And the MRC web pages provide quite a bit of information. So if there are questions that are not answered here, there's a pretty good chance those will be answered on the web page. In any event, there is a hard deadline for applications, and that's February 15th at 11:59 p.m. I'll mention finally that this program has generous support from the National Science Foundation, and as well as from the American Mathematical Society itself and some private donors. So we're pleased to be able to offer that support. So our panelists today are listed here. The 4 bullets, excuse me, the 4 bullets list those panelists in the order in which their MRC summer conferences will take place. So the first one on Ricci curvature starts in late May, and the others run according to the schedule on the webpage. So I won't review that here, but suffice it to say that's the rationale for ordering these. So we have for week 1, Linyuan Lu and Jiyu Wang, and they'll be talking about Ricci curvature. Samya Sankar and John Voigt will be discussing week 2A on explicit computations with stacks. Matt Ballard from the University of South Carolina will talk about derived categories, arithmetic and geometry. That's week 2B. And then finally, Alexandria Volkaning will be talking about the MRC in week 3 on complex social systems. So without further ado, I will turn things over to Linyuan and Jiyu to talk about the Ricci curvature MRC.
Yeah, thank you, Tom. Hello, everyone. My name is Zhiyu. I'm a third-year postdoc at Georgia Tech. Yeah. So our topic for the summer workshop is Ricci curvature of graph and applications to data science. And our organizer team consists of Fan Chang from UCSD, Mark Kempton from Brigham Young University, Wu Chen Li, and Dr. Linyuan Lu from University of South Carolina, and me from Georgia Tech. So our team, we work on a variety of topics, areas including graph theory, random graph models, spectral graph theory, Ricci curvature, and then optimal transport and machine learning. And hopefully, our goal is to bring people from different areas and then try to work on problems, try to create some interdisciplinary studies. So curvature, just like a very brief kind of introduction, curvature is a very central concept in differential geometry. And then, so we are working with discrete spaces. And then, so there have been several kind of discrete analogs of curvatures, specifically on metric spaces and also on graphs. So starting from the combinatorial curvature, which define on the vertices of a graph on like a surface tessellations. And then there have been several kind of discrete analogs. And name a few. So there are this Oliver-Ricci curvature, which is defined on the vertex pairs of a graph, and then based on the y-system 1 transportation distance. So generally, people try if a graph has positive Ricci curvature, then the idea is that the average distance of the corresponding points on a small ball along two vertices are smaller than the distance between the centers of the balls. So that's an idea based on optimal transport. And then there are several others in particular. There are some kind of modifications of Oliver's Ricci curvature, which is the Lin-Lu-Yao Ricci curvature, and then also the Lin-Yao Ricci curvature, which is based on the kind of like a heat semigroup extending this Bakery-Emery notation. And then there's also this extending this idea of Sturm, Lotz, and Villani, Amber, and Mas also have this global Ricci curvature bound based on the convexity of Boltzmann-Shannon entropy on the space of probability measures along the geodesic. So which is kind of based on like a modified version of the W2 y-system distance. So this kind of different, there are several all these different analogs of curvatures in graph, which have a lot of connections to different areas of math, including spectral graph theory, including a lot of applications in data science. In particular, we know the spectral gap and also the Ricci curvature lower bound of a Markov chain. They play a very important role in estimating the rate of convergence of a MCMC algorithm, and also the error estimates for empirical means of certain functions. And then recently, there have been also a lot of applications of Ricci flows of graph in terms of in the area of community detection, and also measuring clusterings of networks. So our goal is to kind of like bring together people from different area and then work on a wide spectrum of problems in these areas. We hope that we hope to design this workshop such that people don't need a lot of background, and also like people from different areas can focus on the areas that they are comfortable with. So if we have people from graph theory, they can work on problems in extremal problems in graph that satisfy certain curvature conditions. So we can work on purely on like a graph theoretical problems. And if people coming from applied side, there's certain also certain applied problems involving algorithms that people can work on. So that's our kind of the overall goal of the workshop. Yeah. Professor Lu, do you have anything to?
No, I think you said very well. I think it's a very compact summary about this area. This just I would just want to say this area is kind of like an emerging area, and a lot of concepts related to the last 10 years, 40 years, and have a lot of like connection to in other areas. So I think it's good to have more people know about this one and have more people join this area. That's why we organize this workshop. Thank you.
Thank you.
Okay, thank you. And I think we're ready next for Soumya and John to talk about explicit computations with stacks.
All right, thanks. I'll go first. Soumya's here too, so she'll chime in at the end, make sure I don't forget anything. So our MRC is on explicit computations with stacks. The five of us, Andrew Coben, Soumya Sankar, Libby Taylor, me, and David Zerk-Brown, we're all really excited by this idea of small groups, focused problems, gaining understanding, trying to make things intuitive. And so we tried to design this proposal with that in mind. So what do we mean by explicit computations with stacks? Well, what is a stack after all? Sorry for the using slides, but it's mainly to show you this reassuring kind of picture. When we think about stacks, I don't know, they're fluffy and delicious, right? Or, okay, there's a reputation that stacks are the kind of thing that are unknowable because of their level of generality or perhaps how technical they are. But actually, they're also really useful. And so within kind of, this is a topic in algebraic geometry, number theory that touches on other areas like topology. And what we'd like to do is to, without a lot of category theoretic nonsense, really try to make this picture come to mind also when you hear the word stack. So to be a little bit more precise than that, where do stacks naturally show up? Well, whenever you have objects that you want to parameterize up to isomorphism, it's often the case that some objects retain extra automorphisms. And somehow one of the things that the stack is supposed to do is to remember this additional information. And one of the main foci of our MRC will be thinking about this in the prototypical case of the moduli space of elliptic curves. Elliptic curves are your favorite donuts. They're parameterized by a J invariant. And here's kind of a picture of what happens when you try to parameterize these in a natural way. Something doesn't quite add up. It goes wrong when you look at the family, and nothing is wrong. It's just that you need a stack, not a variety. It's not simply given by a parameter, but there are two elliptic curves with extra automorphisms, those with J invariant 0, 17, 28, corresponding to the square and hexagonal lattices. And so that's I hope that's already kind of intuitive for what a stack is supposed to do. Another very simple example of where a stack shows up is when a finite group acts on a space. Whatever we mean by space, it can have points with additional stabilizer. And this goes back to the original definition of a Riemann surface, where you have z goes to minus z, and you try to imagine what the quotient space looks like. Now it kind of looks like this. At the origin, somehow it only has half of a neighborhood around that point. And the stack remembers this additional stabilizer around that point. Sometimes in topology, these are called orbifolds or conifold points. And so with those two slides, hopefully you're now convinced that stacks arise naturally in mathematics. And so what do we do? How do we get an MRC out of this? Well, what makes stacks hard is that they're very general. I mean, they're more general than sheaves, varieties, topological spaces, or even groups. I'm actually proud here that I found out how to include emojis in LaTeX. That's the kind of sort of natural thing that you're led to when you're asked to give a talk about stacks. That's a brain exploding emoji. Maybe you had that feeling too the first time that you took, I don't know, an abstract algebra class and learned about something very general like a group. How do you get to know what groups actually look like? Well, you do things like compute explicitly with the dihedral group or the symmetric group or a cyclic group, and you try to gain familiarity by working concretely with it. So we have several problems that we are thinking about that will lay out the necessary infrastructure to achieve. And what we hope to do is to have these very concrete questions about stacks. You learn about what the stacks are, but you also solve a problem that is somehow framed naturally in the context of stacks. So one that I've been thinking a lot about, of which there's a lot of recent work, is how many elliptic curves over the rational numbers have an n-isogeny. So an n-isogeny is certain homomorphism between elliptic curves. An n-isogeny is one where the size of the kernel is n. And as we saw, moduli space elliptic curves, something interesting happens around the points with extra stabilizer. And that has non-trivial implications for what happens with the number of them up to a given height. And that is, it's interesting to try to frame this question. You have just an analytic number theory problem that you have to solve, but somehow along the way, what you need to understand is what the stack is guiding you towards. So that's how we feel like this is a concrete question. It's motivated itself, but the stack comes along for the ride. Another kind of thing you might want to think about is, what does an equation for a stack look like? So we make equations in algebraic geometry by taking sections of a bundle to try to embed it into projective space. And so given even something simple like a stacky curve, a one-dimensional object, we might try to compute explicitly what equations for stacks look like, do that in higher dimension. Another thing you do in algebraic geometry is thinking about intersection theory, which can be quite weird when you have these points with additional stabilizer. But there is a way to think about it when you have a group quotient-like situation, which can reframe the problem G equivariantly, and then it becomes, again, something amenable to your intuition, but with kind of a finite group acting at the same time. And staying in that theme, there's also questions kind of very generally, to what extent are stacks described, as in the second slide, as a quotient of a variety by a finite group. So I hope I convinced you sort of what motivates stacks, so what kinds of ingredients can come into it. And we really hope that you'll join us. So what kind of background do you need in order for this to be a meaningful thing? Well, you need to know some algebraic geometry maybe at the level of Hartshorne, or your favorite algebraic geometry book. Some arithmetic geometry, like about elliptic curves at some level of Silverman, would also be useful. That's kind of bread and butter, PhD, graduate school level algebraic geometry. That's enough to build upon. But if you know some analytic number theory or some topology, or you love to do machine computation, all of those things will inform your understanding and contribute meaningfully to our projects. And in particular, we emphasize that previous experience with stacks is not a prerequisite. One of our goals is to try to make them accessible as possible. How did I do, Sumia? What else should we say?
No, I think that was perfect. Yeah, and I'm gonna sort of steal what Dr. Liu said. Essentially, it's just that the stacks are also things that have applications very widely, as John pointed out, in arithmetic and algebraic geometry. And you might be working with stacks secretly without actually knowing it. And so our hope is to welcome everybody into like this thing that is seemingly very technical, but we want to like open it up and have more people be comfortable with the idea of stacks.
All right, thanks. Couldn't agree more.
Well, thanks, John and Sumia. Next, we have Matt Ballard, who will speak about the MRC on derived categories, arithmetic and geometry.
All right. Well, I wasn't expecting the shade for categorical things to come right before my talk, but I think I can step above, rise above. I also have things to de-escalate the threatening nature of the topic. Perhaps we have a very cute cat. Okay, cat for categories, perhaps. So I think one of the things that was conveyed very well in the presentation for stacks was the desire to expose the area to a broad audience with people with a certain background level, but who don't necessarily have deep acquaintance with the material. Okay, and the same is going to be true when we talk about derived categories. Derived categories also have a reputation for being highly technical, inaccessible, difficult technologies to work with. Okay, but in truth, with some experience and some examples under your belt, you can go quite a ways. And that's the hope with this MRC, is to provide that. So let me try and sort of set the stage from more familiar concepts to what we talk about with derived category, right? So one of the most common procedures in mathematics is to start with a space of something, okay? Call it X. Could be a variety, could be a manifold, could be some complicated set. We want to try and understand the structure of such a thing. Okay, how do we do that? Well, we try and extract invariants from it, things we can compute from it, that are perhaps easier to understand and capture a wealth of information about X. Right? And so perhaps the most simple thing that we study is you can think about functions from X to something else, okay? So maybe this is the complex numbers, maybe this is the real numbers, maybe this is a finite field, what have you, right? So we can try and understand something by thinking about probing it by looking at all the functions, right? And at least at a base level, you think about delta functions, recovering your points. This is something that doesn't lose a lot of information, okay? And so the nice thing about this structure here that isn't necessarily inherent in the space X we're coming from is that there's a natural way to add and multiply elements of this new set, right? And you can scale them by elements of the target. So you naturally form a ring out of that, okay? And then the structure of that ring, we could do algebra upon and try and understand, okay? So understanding the algebra gives us some insight into the geometry in these two ways. Okay, and to go to derived categories, we kind of want to take it one step further. In general, when we're talking about varieties, especially varieties that are closed up, compact, complete, some of these words that usually describe them, they're not a lot of global functions, right? So we think about local functions, and when we have rings, as we've seen in our graduate algebra class or undergraduate algebra class, one of the natural things to think about with the structure of rings is to think about things that they act on, modules, right? So we have rings, really they're commutative rings. And then we can go here to modules over a ring, okay? And so how much information have we lost when we think about modules over a ring from the original space X that we have? Okay, well, we're getting pretty close to a derived category now. All we have to do is put these modules together in certain configurations, collections of maps between them, and then identify them a little bit with some homological motivation, okay? And so that's how we get from a space to its derived category. We pass to sheaves of modules over the sheaves of functions, and we try and understand complexes of such things and how it influences the structure of the space itself. What's it good for? Well, surprisingly, it seems to be good for a lot of things. So one of the most important motivations, one that we will definitely use as inspiration at the MRC, but won't give you the background for, is physics, in particular, the basis in string theory. So these objects can be thought of as boundary conditions for a string propagating in your usual familiar four-dimensional space across a very small six-dimensional space with very special properties. And the interactions between these boundary conditions are at a very low energy level represented by the relationships between these complexes of modules. Okay? It turns out that derived categories are really useful for bridging algebraic geometry and X, or X maybe is physics, but it's symplectic topology. In a lot of cases, it's non-commutative algebra, representation theory, is it a useful bridge in a way that we really don't have a deep, I wouldn't say we have a bad understanding for, but it's really something that I think we can deepen our understanding as we go forward as a community as to why derived categories are so fundamental in trying to understand something like this. Okay, so let's see, I've been going probably for enough. So in terms of background that we're gonna look for a participant, I think it's fairly similar to what was given for the stacks. You want to be someone who has experience with algebraic geometry, commutative algebra, or arithmetic geometry. Right? You don't necessarily have to have experience with much homological algebra, but that'll be helpful as we go along. We have an organizational team consisting of myself. I wrote down these notes because always when we have to give a list of names, I don't forget anyone. Katrina is here as a participant. I thank you for coming. Katrina Honix, who is at Simon Fraser. Danny Krashen, who is at Rutgers. Katrina says hi. Alicia LaMarche, who is at Utah right now, and Manuela McCree, who is in Paris. Okay, so this is the organizing team, and we've recruited a group of young experts to be mentors on different topics. And so these topics are chosen to kind of hit the key areas of research in derived categories that we see today. So Laura Pattusi, who is in Milan, will help lead a group on bridgeland stability. Eleonore Faber, who is in the UK. I get my different countries in the UK mixed up, so I'll stop there. We'll lead a group on non-commutative prep with resolutions. Alicia Rizzardo will talk about enhancements of categories. Peter Belmont will talk about computational approaches to questions in derived categories. And Alex Perry will talk about homological projective duality. Okay, each of these will be paired with an organizer, and we'll lead one of the 5 groups we have there. Okay, and so my invitation to everyone here is to consider, if you have the background, consider joining us. We aim to make it an experience where you deepen your understanding and hopefully see, even if you're not working in derived categories directly, you see it as a useful tool, and it's something that informs your understanding and your approach mathematically as you go forward. All right, that's it for me. Thank you. Let's see if I can stop sharing.
Okay, thank you. And we're ready now for Alexandria Volkany to talk about the MRC on complex social systems.
Super. You can hear me. You can see my screen. All right, everybody. So we are week 3. This is the MRC on complex social systems. So it's organized by these folks here. Heather Brooks at Harvey Mudd, Michelle Fung at Caltech, Mason Porter at UCLA, and myself, Alexandria Volkany at Purdue. So I'd say amongst the organizers, we have at least 3 folks who've been participants and organizers of past MRC conferences. So I will jump on to what Tom said about it being a really wonderful experience. And I think that that's why we're back for more. So in terms of what are complex social systems, I just have one slide with a few examples of these for folks who are new to that area. But I think of social systems in general as being problems where you have individuals that come together to create some collective group dynamic that is bigger and richer than the individual pieces, right? So in some sense, the MRC is a complex social system. And so we're specifically interested in complex systems that come from social science applications. So these are things like opinion dynamics, it's questions about how echo chambers form, it's questions about how different voter dynamics lead to different election results, it's questions about how ideas propagate through social media. It can be spatial questions like how do you design methods that minimize traffic jams forming on congested roads, or questions about pedestrian movement in airplanes, for example. So really kind of a very broad set of applications fall under this kind of field of complex social systems. And I think what you should also get from this whole image is really that there's also a broad amount of mathematics that these types of applications can be treated by. So really, we are going to think very mathematically broad and really interdisciplinarily in our MRC here. So I think in terms of background, really the main thing that we'll be looking for is folks who are interested in questions related to complex social systems and social science. Really, you have some experience with data analysis, that would be lovely. But really, in terms of problems, it will run the gamut. The organizers have ideas related to, for example, coupling biological disease spread with models that account for human behavior and opinions more. We can think of looking at data related to elections in the US to think about how do we develop methods for forecasting elections better. We can think about more mathematical questions related to, for example, if you're given some data, how do you learn models for opinion dynamics from that data? Another question could be, say, so one thing we have access to is data on redistricting at the local level. So if you think of questions related to gerrymandering, and specifically questions related to gerrymandering at a local level, how do we understand, for example, from transcripts of public meetings where community members talk about gerrymandering, what kind of types of arguments in a public meeting lead to action in that community, right? So this would be more of a text analysis question tied very closely to a social science application. We are also working on bringing in community partners who can help drive questions that are really heavily focused in social science data and in questions that are important to community members. We also expect that there will be questions that are kind of motivated by social science, motivated by social complex social systems, but much more kind of mathematically focused, where the interest is in bringing new mathematical methods that are motivated by these systems. So with that, I think that's really all I want to say. And yeah, I'm happy to take questions when the questions open up.
Very good. So thanks everyone for giving some summaries on the respective topics. We come now to the Q&A section of the webinar, and this is your opportunity, attendees, to raise questions for our panelists. Probably the simplest way to do that is to raise your hand. You can do that using the reaction button at the bottom of the page, and what we can do is recognize you and let you direct your question where you'd like for it to go. So don't be shy. This is your time. Okay, so first I see Kate. So if you would, when you come on, introduce yourself and maybe your institutional affiliation.
First, excuse me, I'm getting over laryngitis. I'd like to thank you all just for coming out and telling us about this, the research community. It's been really nice. So I graduated from Harvey Mudd in 2011 and spent 3 years at University of Minnesota before I had my first daughter. And I've actually been away from mathematics for 8 years and really miss it. So I'm hoping this can be my break back into the community as I'm applying for graduate school again. But my question was for Alexandria. I'd really love to be on the border of dynamical systems and graph theory. And your project seems the most likely to have an in for that. Would you agree with that, or
Well, I think that in terms of the different MRCs, I think that those organizers could talk about the fit with dynamical systems and graph theory. I think that there's certainly a fit in our MRC if you're interested in looking at those types of things from the perspective of the application, because we're really going to be thinking of the applications as driving the math. I think that things like geometric data analysis, topological data analysis certainly come up when you're working with spatial data, say, for example, data on gerrymandering. And applied dynamical systems, when you're thinking about mathematical modeling, is certainly a method that I think some folks will use in our MRC.
Thank you.
Hi, my name is Wei Hong. I'm currently a postdoc at Virginia Tech. I'm interested in the stacks and also the derived categories programs. So my first question is, what will happen if I apply to both? And my second question is, how do you put participants into smaller groups? Like, how do you decide which group to put them in your program? Thanks.
I might be able to answer the first question. There's nothing preventing you from applying to more than one MRC. The respective organizer groups, though, consider the applications they receive independently. So the decisions about admission are independent of one another. And our practice is to do the following. If someone is admitted to 2 MRCs, for example, and that would be that we turn to the applicant and say, you pick which one. So that's what we anticipate doing this time around. As far as forming smaller groups, I'll leave it for the panelists to indicate maybe how they want to approach that.
I can go first if people wouldn't mind. All right, so the plan is the following. The mentors that we named, along with the organizers, will put together sort of onboarding materials. The exact form of that is going to be left up to the mentors, whether it's going to be videos, whether it's going to be notes. The point of these materials is to get people from the point where they're in to have an appreciation for the general landscape of the area. And then through discussions on some group chat messaging board like Slack, not really Slack, more like Zulip, for instance, people have a choice of what areas they want to go into. Okay, and then we'll group people according to the choices, their preferences as best possible, trying to maximize everyone's satisfaction. And then even after that, once there will be some time between when that happens and when we have the actual week in person, there'll be discussions trying to get people set up and prepared to work on specific problems in those groups. If people want to switch, that'll be something that'll be perfectly valid too. So if they want to switch, both parties are go, they can switch groups like that. And so the idea is that people, when they arrive to the conference center, are already focused on a particular idea or a particular collection of problems, and are ready to go, ready to hit the ground running with their mentors, with the organizers, and with the rest of their small group. So that's our vision for that.
Any other panelists want to?
Sure. Our ideas were similar in the sense that there will be some pre-workshop activities happening. So some of this could include discussion boards, like small little videos or talks, and reading material to basically talk about different kinds of problems. And by being a part of the discussion board, you'll get an idea of what kinds of problems are there, like even like apart from the ones that John mentioned, like what kind of background and what kind of reading you would need to do for each of these. And then you can decide roughly like what category of problems you would be interested in or you have the background for or would want to read more about. And then once closer to the MRC and actually like the first day of the MRC, we'll actually do the part of like physically separating people into groups and having them work on problems. And of course, if you think that you do have the option of changing your group as well. It's not a hardcore commitment. I don't know if I missed something.
Oh, no, thanks for answering. And for the derived categories, you mentioned some mentors, and the list of mentors seems to be different from the list of organizers. Is that right?
Yes, they're two separate groups. So the organizers, the mentors pair to lead each small group. Okay, so we get energy from young experts infused into each group, along with organizational energy from the organizers to try and have more than just one person who's in charge of making sure that everyone stays moving forward on a problem.
Thank you.
All
Just wanted
right.
to say one other thing about, sorry, Matt, about the category theoretic shade. In fact, I think it's really awesome that the AMS has organized our 2 weeks at the same time. So we're definitely going to hang out. And I don't think that it's really, I mean, for the week, any of those of you who are out there figuring out, I think you'll want to pick one and not try to do two at the same time. I mean, that's just not going to be possible. But on the other hand, it's really convenient that in the Venn diagram, there's some overlap. And so there'll be algebraic geometry in there quite broadly. And I think that will make for a very rich week 2A and B. But I'm going to keep throwing shade.
Okay. Well, we'll first move to a question by Tuto, and then I believe we have some in the chat after that.
Yeah. Hello, can you hear me?
Yes.
Hello, everybody. My name is Tuto Lopez Gonzalez. First, thank you so much. This has been really informative and useful. So I appreciate it. I've been able to learn a lot, although I've been looking at the website too. I do research in mathematics education. I'm from the University, San Francisco State University, and I'm interested mostly in Alexandria and GU groups. So probably will apply for both. I do specifically in things related to cognition and how that might be modeled as a complex system. Anyway, and then the question that I had for you is if you can share a little more about the opportunities for follow-up and future collaboration. Thank you.
Should we take that, Tom and Karen, or?
Yes.
I think okay. I'd say, so the past MRCs that I have been part of, I have always kind of made use of these different resources that Tom mentioned. I've always gotten to meet with my collaborators again, gone to the JMM, and usually set up weekly meetings. So they've weekly meetings. And I think that MRC is one of the really, my favorite thing about MRCs personally is that, especially for folks who are kind of moving different places, maybe, if you're in a graduate student role or a postdoc role, it's kind of a community that stays with you even when your location is changing, because you can do these virtual meetings and continue the collaboration. I'd say for our MRC, the organizers are coming in with some project ideas, but it's also possible that projects will come from the participants themselves. So we all get in the room and we realize that there's all sorts of these different types of expertise in the room, and that there are natural projects that can come out of that. So part of it will depend on participant interest, whether or not they want to continue the collaboration, right? But I'd say that's my goal, at least, for there to be kind of continued meetings after that, and to hopefully build a collaboration that can maintain, or mentorship community that can maintain.
Any others want to respond to Tuto's question? Okay. Well, we've got some in the chat. One comes from Yonwook, and Yonwook has asked, just to be clear about applications, what does pre-PhD 2 mean? And indeed, that does mean 2 years before receiving a PhD. So if someone is a graduate student and anticipates finishing in the next 2 years or so, then that person is for sure in the range of eligibility. So I think that's a question that I can answer on that front.
The other question is it possible to attend the MRC program given the fact they already attended last year?
That's one of those situations that is on a case-by-case basis. There would need to be a rationale articulated in the application, and the organizers too would have to be amenable to that. So those are the two criteria. And I would say for a short turnaround like that, that case would have to be fairly strong. Okay. And then one other question that I think is probably also directed more for AMS. The question is it possible to attend any of these workshops virtually? We actually do work hard to make the experience one that is most beneficial in person. So that is what we want to strive first and foremost to be able to do for each participant. That said, well, on individual cases, there may be ways to address limitations. So I would say that that's a question to put into the application materials if you're applying, and see that as a necessity. So.
It looks like we
Right.
have one hand up.
Yes, Devendra.
Yeah, so I'm from India. I would like to hear if there is something special to care about for applying and attending the program. I have put the message in the chat box. I'm interested in this text. Are you able to hear me?
Does one of the panelists want to? Well, I guess actually this is. Go ahead.
Yeah, I'm sorry. For our project, I don't think there's anything special to take care about. The only thing I would recommend is like if you need to get visa situations sorted, try to get that started as soon as you know about the about the status of your application. But that's about it. I think maybe you already know that. Sorry.
Yes,
Thanks.
I can certainly second that. So yeah, that is an important consideration. That is probably the single thing that can be one of the greater challenges to overcome.
Tom, do you want to say something like we are considering both domestic and international students? They're in the same application procedure, so it's not like they have to be flagged separately. I mean, hi Devendra, how's it going? You might want to make sure that whatever background that you have, or any of you out there, to make sure that we understand what level it's at. That will also help us to when evaluating those applications. But otherwise, I think it's the same argument, unless the AMS has some other constraints that they would like to say about.
You're exactly right, John, and thanks for bringing that up. So yes, the evaluation of applications is pretty much indifferent on that point. Now, there is, because this is an NSF supported program, there is actually a limitation on the proportion of participants that we can fund who are international. So that is one constraint that we labor under. So that in the end could be a consideration, but that would depend upon the characteristics of the applicant pool.
Okay, thanks.
And Karen has put into the chat an email address where you, if subsequent to this webinar, you can send other questions if you have those. Okay, we are actually coming up on the nominal end of an hour. Are there other questions in our among our attendees? Had some good questions here, good discussion. And we're certainly able to take another question or two before the nominal time is over.
Oh,
I see
There's
Rebecca.
good question in the chat. Sorry.
Oh.
Go on. Maybe. No, you can go.
Hi, my name is Becca. I am a PhD student in math education. Also, I'm over at the University of New Hampshire. So Alexandria, I'm primarily interested in your project on social systems. I was just wondering if you guys could speak a little bit to the application process and like how you evaluate applications and maybe a couple of pro tips for people applying and what makes a successful applicant in your eyes.
Okay. So I'd say first, just interest in the area, right? And also, what else? Like being a person who wants to work on a team and collaborate and all of that. The other thing that I think would be useful to address is if there's some reason why this would be like particularly beneficial for you now to participate in this workshop, right? I think that that's something that we'll be sensitive to if there's a reason like that. So I would keep that in mind. You can, there's all sorts of reasons to apply for an MRC. The MRC that I did was on sea ice. I've never done sea ice in my life before that MRC. And the reason was to I talked about what it meant to me to kind of move into a new area. So for some folks, they might be applying to an MRC because they're an expert in the area and they want to build collaborations in that area and all of that. Other folks may be moving into a new area and that the participating is a way for them to jump that bridge, right? So just to talk about why you want to apply, why it's a good time for you to participate, and then maybe some of the types of applications and questions that you're interested in.
Thank you.
Just to address one of the questions in the chat, I was because it was a good question, which is that what a daily schedule might look like. So one possible way, one thing that we had in mind was basically have people work in groups during the mornings and then the afternoons. So have a few hours allotted for that. And within this time, you can do a combination of things. You can read papers, you can work on your problem, you can assemble things, you can also talk to experts. During this time, you can walk around, talk to everybody else. And then during the rest of the time, there'll be a lot of unstructured time where you also get to talk to a lot of people. You can still continue working on the problem if you like. And we'll also have some talks to start off each day that basically talk about certain topics within stacks and related topics that you sort of need for example, some maybe background in group actions on varieties or how to count points on things or some stuff like that. And then there will also be some professional development sessions towards in the evenings. So it'll be a combination of all of these things. Hopefully that answered part of your question.
So we have a thumbs up on that. I think the question was answered. All right.
We had one more question about wondering whether or not participants can bring their children if they're the sole or primary caregiver.
Generally, the MRCs are not particularly well suited for having family there. So in those situations where that's a constraint for someone, I think best way to handle it is, again, to if you are accepted and have that as something to deal with, then you would work with our meetings people who are very good at figuring out how to manage solutions for those kinds of questions. We really do want all the participants to be able to be on site if possible, and to interact with one another with relatively few constraints from the home environment. That's why we go out to a place in the woods. But that said, there are things that are sometimes individual circumstances that have to be dealt with. So we deal with those on a case-by-case basis. All right. Other questions? This is about the end of the time that we have allotted for this. So, well, with that, then, Karen, if there are not any other hands raised or questions in the chat, I think we can draw our webinar to a close. So again, thank you, organizers, panelists, for being here today to answer questions, engage in conversation. Thank you, participants, who've raised some wonderful questions, and thank you for your engagement. You can follow up with the email address that Karen put into the chat, ams-mrc@ams.org. And do remember that the application deadline is February 15th. We encourage all of you to be safe, stay in touch. Thank you.